All right, let's try one that has, two levels to it, a numerator and a denominator. I had one stored here I was going to do, but it ended up being pretty hideous. When I was looking for the critical numbers, I had to use the quadratic formula. So I changed it. Yes, I did. I changed it to this one. And so let's take a peek at this guy. Again, we have to harken back to pre-calculus. What do we know there? Okay, so in our studies in pre-calculus, what we have is, well, we can write this a different way. We can simply go, it's 1 over maybe x plus 2 and x minus 2. And here comes the story of the vertical asymptotes. Remember, vertical asymptotes are, numbers that, x values that cause divide by 0. So we have a couple of them. We have x is equal to plus and minus 2. If you were in pre-calc, that would cause me to start graphing right away. I'd mark off like this is minus 2, bippity boppity boo, and this is 2, bippity boppity boo, and I know that's no man's land. You can't cross that thing. What else do we know? If you look in the numerator, can this fraction ever be 0? No, only the top is 0 causes the whole thing to be 0, so there are no x-intercepts. It's always fun to find a y-intercept unless it causes divide by 0. So if we plug in 0, what do we get maybe here? It looks like we would get negative 1/4. Okay, and if you're in a hurry, I know some of us are, you can go, okay, 0 and negative 1/4, let's pretend it's right there. Okay, so in pre-calc, oh, and also finally the horizontal asymptote. Can you figure that one out? Horizontal asymptote. Well, that's what the tendency is for the function when x goes to plus minus infinity. What's going on there? Well, in that case, looking at the power above and below, right there, the power below is bigger. So this thing is actually going to go to, what is it? Y is equal to 0. It's going to crash towards the x-axis. So you might put that in here as like the tendency of the curve at the extremes, and I'll make this red too because it's pretty. Okay, so that's our template for pre-calc, and that's as far as pre-calc takes us. It says, okay, graph it. So you know what we're going to do. We're going to take this guy and we're going to derive it. So let's see what we have. We have, first of all, g of x is given to us to be 1 over x squared minus 4. So let's go for g prime. G prime of x. Yeah, right, you got to do the quotient rule. So the quotient rule says, you know what it says. You're going to take this guy. This is the way I do it every time. I square it, then I send it up top, and that gets me. Now you derive 1, you get 0, and then minus 1 and times its derivative downstairs is merely 2x. So we clean that guy up, and we have a negative 2x over this guy, x squared minus 4 quantity squared. Is that right? I think that's what we get. I think I'm happy with that. What do you guys think? Okay, so, all right. We know the critical points downstairs still exist because look, if you plug in x is equal to plus or minus 2, you're in trouble. Let's divide by 0. The derivative doesn't exist there either, okay? And there's a new guy in town, though. Upstairs, if x is equal to 0, right? If x is equal to 0, we've got the derivative is 0. So I'll say it this way. G prime equals 0 at x is equal to 0, and g prime does not exist at x is plus or minus 2. These are your critical numbers, okay? So the story is, to get a better feel for this function, we have to take a look at the signs. So that we mark off negative 2, and in fact, it's a good idea to tell yourself, by the way, that's an asymptote. We mark off 2, another asymptote, and don't get fooled. And then we also mark off 0, and we test the sign of g prime, which is a negative 2x over etc. Now we're looking at the sign of this thing, where it does not exist in between those regions. Okay, and what I notice as I'm testing the sign here is, before I even do anything, I notice the denominator is a square, so he's always positive. I also notice there's a negative out front too. So this region would be negative and then a positive, and a negative in front and a positive down below, and one more negative and a positive. I'm just checking the signs, right? And then you go, well, all right, let's check x is -3 maybe. Well, -3 will be 2 times -3 is negative. The top becomes negative. Okay? The net result here is that this is positive. And what that means to us is it's increasing. All right. Go to the next one. You plug in a -1, same result. It's negative. So again, it's double negative and a positive is positive. I check it by the signs. 2 negatives make a positive. It's increasing. Now we plug in, how about, that was x is -1. How about x is equal to 1? Well, now the top is positive. And if we go x is equal to 3, also positive. So these guys have the same sign, but this time it's negative and then negative again, and it's decreasing and decreasing again. Weird. Do we have anything that resembles a max or a min here? If so, speak up. We do. Right here, it's going up and then down, we have a max. So we might tell the world, look, G is increasing on, and it's these two intervals here. You know, I'm just going to put the two together. That's totally fine by me. So minus infinity all the way to 0. But you know what? That's an asymptote, so maybe it's better not to do that. So I'll say minus infinity to -2 and then -2 to 0. And G is decreasing on, and here's where you would go 0 to 2 and then 2 to infinity. Okay, and we also said G has a max of, and you go G of 0, and guess what? It's up there already, equals -1/4. Now that's something pre-calculus doesn't give you. It doesn't tell you that. So when we look at this picture and we're trying to graph this thing, what we would do is go, well, it's increasing, then it's increasing, but I know that this is a max right there. So from our pre-calc, let's see, whoa, there we go again. From our pre-calc, gotta get this thing scrolling again. From our pre-calc knowledge, what we have is, well, oh no, it's still doing it. Come on, behave. Oh no, don't do that. Where's my, there you are. I'll either save this or not. Okay, I think we can save this particular video. I'm just trying to graph the thing, right? I think what it does is it's a max, so it must be doing something like that. Now here's the funny thing. Remember, oh good, it's scrolling for me now. The funny thing is that it's increasing, increasing, decreasing, decreasing. How does that happen? Well, here's how. On this side, it's increasing towards that asymptote, and then it's increasing towards that max, then it's decreasing away from the max, and then it's swooping down away from on the other side of that asymptote. That's what's happening. We need to check concavity now. I know you don't want to, but let's do it anyway. So we will check concavity next. And so G double prime is coming up, okay? And then we'll go back to the graph and see what's going on. So this is the derivative. Here comes the second derivative. There's a negative in front. I square the bottom, which means x squared minus 4 is now the 4th power. And then I bring it up, x squared minus 4 squared. Derive the top, and I get a 2. And then minus 2x, derivative of the bottom, is times 2. And then we have x squared minus 4 to the 1, and then times 2x. Glory be. It's really something. Now here's a funny thing. I'm glad I'm doing this video with you guys. The funny thing is that if you look here, before you start combining all this stuff together and getting a big old polynomial, you have a common factor. In fact, you can also take out a 2. You should do it. So there's a minus. I take out a 2. I take out an x squared minus 4, just one of them. And it leaves you behind, let's see, one more of them. There's still another one, x squared minus 4. And then we have a minus, and then there's a 2x, and then another 2x. Are you kidding me? No, sometimes it is like this. We have x squared minus 4 quantity to the 4th, And here we go with some fun. We can cancel one of those guys, and that actually helps us find the sign of it. And we're getting a derivative that looks like, oh, I don't know, it's a negative, there's a 2, patience, x squared minus 4 cubed. And inside here is a mess. We have 4x squared plus 1 is minus, where's this going now? We've got, yeah, it's going to be this. It's going to be minus 3x squared and minus 4. Okay. I'm going to take the liberty of maybe taking that negative and just putting it inside there. So what I'm getting is a g double prime, the second derivative, looks like it's 2 paren positive 3x squared plus 4 all over the cube of this guy, x squared minus 4 quantity cubed. Whew! Okay, so the possible inflection points are, well, let's do this in red again. That's what color we chose last time. Downstairs, we still have does not exist at x equals plus or minus 2. Upstairs, is there a solution to that to make the second derivative 0? Look at that. There's no way you're going to pick an x that's going to cancel with 4 when you square it. So g double prime is never 0. So the sign changes of your second derivative, should they occur, only occur at negative 2 and 2. And what's special about those points? Asymptotes. That's what they are. So we're going to check the sign of the second derivative now. Okay. Here's the thing. Let's plug in. What I notice is upstairs is just all positive. Do you see that? It's 2. It's a square plus, yeah, it's all positive. It's downstairs that makes the difference. So, for example, if you put in a negative 3, or if you put in, say, a 0, or if you put in a positive 3 here, okay, then what happens is the negative 3 down here is 9 minus 4 is positive. Positive. For 3 also. But if you plug in 0, look at negative. What does that say about concavity? Well, the whole thing is positive here, up. The whole thing is negative here, down. And the whole thing is positive here again, up again. Okay, are there inflection points? You might want to say so. Yeah, concavity changed here and here. Are these points? Remember, those are vertical asymptotes. You know, many a student has fallen for that trap. But what we can say is we could say F is concave, let's say up on, there's a couple of places, right? It's minus infinity to minus 2. And also, what else? A 2 to infinity. F is concave down on, say, minus 2 to 2. And you might finally say F has no inflection points. Oh, darn, no inflection points this time. Finally, let's go back up. Concave up, down, up. Does it match what we've graphed so far? I think you'll agree it does. Look it. It is concave up, it's concave down, it's concave up again. Yay! And another graph is done. There you go. Rewind and watch that thing. That's how you handle it. That is actually a simpler rational expression. So obviously try your hand at these guys. I am going to look at the next one to see if I want to make a video. I think it would be nice. We'll see. All right, that's it for this one.